Okay, so yesterday we learned about prime expressions in our factorization in algebra. Today we're going to look at using the greatest common factor and establishing that so that we can factorize correctly in algebra. I would like you to press subscribe below. If you're not one of my subscribers, you're welcome on board and I can help you daily with your maths. I have videos from grade 1 to senior school on my channel. Right, so factorization using the greatest common factor of a polynomial means that you have to find the greatest common factor of each term of the polynomial. So let's go do a few so you can get a bit of practice. Right, so we're going to have two steps. We're first going to establish what the greatest common factor of each term is, and then we're going to place the greatest common factor in front of the parentheses and divide each of those terms by the greatest common factor. And I want you to notice that the value, once we've done that, has not changed. All we've done is taken out the greatest common factor. Like when you would reduce, let's say, 4 over 8, it would become a half because you use divided by 4 and divided by 4. And 4/8 is the same as a half. So it's exactly the same in algebra when you remove the greatest common factor. The value does not change. So let's look at this first one, ay plus by plus cy. What do we have there as a greatest common factor? We have a y, don't we? So we're going to place that outside the parentheses, and if we divided ay, by, and cy by y, we're left only with a, b, and c inside. So let's rewrite it like that. Y on the outside, and then a plus b plus c. Because each of those divided by y would have left us just with a plus b plus c. Okay, you understand why. Okay, excuse the pun. Right, next one. We have no letters that are greatest common factors, but we do have digits that are greatest common factors, and that would probably be 2, because it can go to 2, 4, and 8. So 2 is written outside the parentheses, and the rest are just divided by 2, so that would be divided by 2 leaves us with x squared, and so on. So we'll end up here with a 2 and a 4. So that's why it's written like that in the parentheses. After we've taken the 2 out, we're left with x squared minus 2y and minus 4y squared. Okay, so I think you can probably solve the next one yourselves. Be very careful, look at the exponent. So what is the common factor here? We can see it is an a, hey? But we can't make it an a squared or an a cubed. We've only got one a in this term here. So we're going to take out only one of the a's, which means if we divide this a cubed by an a, we're left with a squared. So that's our first one over there. This one divided by an a means we're going to have ac, which is this one over there. And this one divided by an a means we're going to be left with minus c squared. Okay, so you're getting the picture now. Right, now the last one, our greatest common factor would be p, and we'd be left with q minus r, because if we divided by p on both of them, those would cancel out. We'd have just be a q minus an r. So you've got an idea how to remove the greatest common factor and place it outside. And you can also see exactly true to our rule earlier where it said, notice the value has not changed. This equal sign here means they are still equal. Like when I showed you 4/8 equals a half. They're still equal. If you were to work this back in there, you'd end up with that. Same with this. You'd end up with that. We're just factorizing to make life a lot simpler, because we really have to understand this skill in algebra in order to advance properly in algebra. I'll see you in tomorrow's lecture on factorization in algebra.